Thank you. So yeah, hi everyone. Thank you for showing up. So we will talk about built-in OpenTelemetry supporting the Elasticsearch clients. Just a few words about me. So I'm Greg. I work at Elastic since 2018. Originally, I worked on their .NET APM agent. So if you have .NET applications running somewhere and you monitor that with Elastic APM and the APM agent crashed your application, that's maybe my code. So yeah, that's and now currently I focus more on OpenTelemetry. So at Elastic we wanna support OpenTelemetry as a first-class citizen in our observability product, and that's my main focus. Sometimes I tweet, since this X thing, whatever, I don't like it anymore that much, but I have a Twitter handle. So yeah. I live in Austria, but I'm originally Hungarian, so you can talk to me in German. I speak this weird Austrian dialect with weird Hungarian accent, so it's a really unique combination. Yeah, talk to me in German, and then you can experience it. It's really fun. Okay, so in this whole presentation, I will start with a demo. So I will show you what we are talking about, and then on the next part of the presentation, we will dive into the why and how it works. So I prepared a really small sample application where we talk to an Elasticsearch instance. We just read data, and then we will turn on telemetry and specifically tracing for this sample application. So let me dive into the small sample application. This is, I use .NET here. It doesn't really matter, so it could be any other, Java or Node.js or Ruby or whatever. So what we have here, if you are not a .NET developer, doesn't really matter because it's really simple. So we have an Elasticsearch client here, which talks to an Elasticsearch instance. So we configure the client here, and we read data from this my index. In this index, we have a Twitter, like a tweet with a username and a message. And then we pass that to a view, and then on the view, super complicated, we just render it. And here is how the application looks like. So this is my name, and I just say hello from OSMC Nuremberg. So we read data from Elasticsearch, we render it as an HTML page, and then that's it. I turned on tracing for this application. I use Jaeger. So let me just show you what we see from this application. So who knows Jaeger, by the way? So do I need to introduce it? Oh, not many people. Okay, so Jaeger is basically an open source distributed tracing tool. So it's able to receive, for example, OpenTelemetry data, and it stores it for you, and then there is a UI which visualizes it for you. It's completely open source. It's totally free. So if something collects OpenTelemetry data, you can just point it to Jaeger and then visualize the data, and that's what I'm doing here. So what we see here out of the box is that there is an incoming request, and this is the one which is the key here. So we have one span which represents the call to Elasticsearch. So we see really useful data here. So we know which Elasticsearch cluster we talk to. We know the node name. We know things like the index where we store the data, and we know that this is a get operation. We know that this is an Elasticsearch client, or the database system is Elasticsearch, and we have this out of the box. This is the span which represents the call. Now, you may say, okay, this is tracing. We had it since forever. So what's the new thing here? The new thing here is that in this application that I just showed you, I don't have any agent or any monitoring tool that I added to it. The only thing that I added to this application is I'm showing you the dependencies of the application. The only dependency I added here is an OpenTelemetry exporter. The exporter doesn't do any instrumentation. What it does, it just takes data which comes from some instrumentation and sends it somewhere. And this is the configuration for it. So basically what I'm saying here when I configure the OpenTelemetry exporter is that I have this URL running localhost, that's my Jaeger, and I send the data there. So what we have here is actually in this application, we had these traces, which I showed you in Jaeger, without any additional instrumentation, without any APM or observability agent or whatever. So I didn't install anything additionally. So in the remaining part of the talk, we will dive into the why this makes sense and how this works. Is this part so far clear? Or anyone, any question to this demo? Okay. By the way, if you have any question, like during the presentation, just interrupt me. That's fine. So just ask your questions. Okay. So before we dive in, I assume everyone knows about OpenTelemetry, but just to make sure, who knows what OpenTelemetry is? So roughly. Okay, half of the group roughly. So we will have a 2-minute OpenTelemetry introduction. So OpenTelemetry is a CNCF project. It's a collection of APIs, SDKs as tools. The whole thing is open source. That's the whole point of it. And the goal is to instrument, generate, collect, and export telemetry data. There are the 3 main pillars: metrics, logs, traces. Profiling is another one, which is like an incoming thing here. And this is the basic infrastructure. So you have your applications, like let's say you have a Node.js, a Python, or a Java, or a .NET application, whatever. And then you can add the OpenTelemetry API into your application. And with that, you can capture traces, logs, and metrics. There is also an SDK, which then generates the actual objects, like the traces, the spans, the metrics, the logs. What OpenTelemetry also supports is distributed tracing. So if you have multiple instances talking to each other, you obviously want to have an end-to-end trace across multiple services. For that, OpenTelemetry supports context propagation. So it makes sure that if you have an upstream or a downstream service, then it knows about the fact that if you have a single request across multiple services. And you can put agents and auto instrumentation into your application, which then takes care of instrumenting the application, collecting the traces, and then other part, which is also part of OpenTelemetry, is a collector that, as the name suggests, collects the telemetry data. There is a defined protocol between the collector and the data collection part. This is OTLP, the OpenTelemetry protocol. It essentially defines how a trace needs to look like, how a log needs to look like. And then from the collector, you can send the data wherever you want. So yeah, I talked about the signals, like traces, metrics, logs, and profiling. And then you can send this whole data to a backend, like Elasticsearch is obviously one that we use, or Grafana, or Jaeger, as I showed you in the demo. So this is the big picture of OpenTelemetry. This is like the OpenTelemetry website. It says high quality, ubiquitous, and portable telemetry to enable efficient observability. Now, what the hell does that mean? This is really like a marketing slide. So let's dive into this ubiquitous part, because I think that's really important. And if you want to use traces, then this is something which is a real thing. Just the formulation is like a little bit, marketing-y. So here is how an application today looks like. You have a class, you have a method, and this method, returns a view. And obviously, you have frameworks and libraries in your application. So in my example, this was an ASP.NET Core application. So you derive from a control class, and from that point, ASP.NET Core will take care of rendering it. If you are a Java developer, then Spring does something similar. So it basically it's a web framework, and then you use a whole bunch of libraries. So let's say I add an Elasticsearch client to the application, which talks to Elasticsearch. This is what we saw in the demo. Just to have another dependency, you can have Kafka as a dependency in your application. Then again, that's another library that you use in the application. And if you want to use observability, if you want to observe this system, what we expect from this as an output is something like this. We want to see traces, logs, and metrics. And for traces, we want to know, oh, there is one span representing the whole incoming request. We want to see, okay, there is another span representing the call to Elasticsearch. We see the duration of it, and then we see another one for Kafka. Plus, we want to know, want to see all the logs from all these frameworks and libraries. If there is a warning, we want to see that, and obviously we want to know metrics like what's the latency of my application. Now, how can you achieve this? What ways do we have to achieve something like this? Well, it's instrumentation. So here we have this code from the previous slide, and what you can do is just have some API. What I'm using here is the OpenTelemetry API. And create those spans manually. So here we, in this part, we just create a span for the HTTP call that will have a name, HTTP get index, because we know that this is the index method, and then it will have a duration. And then we have a call to the Elasticsearch instance. Again, we create a span for that with the name. And then we have one for the for Kafka. Now, what I don't show in this slide is obviously we wanna also capture other things, like I showed you. We capture the Elasticsearch instance, the index name, all sorts of like Kafka, what the message is. You wanna see these kinds of things in your observability tool. So that would be even more code. And if you have more dependencies, then you would do this for every single dependency, which is impossible. So imagine a world where you have this for free. Basically, in my demo, I showed you that you can get this for free. Like some tools already emit this telemetry data. Now, you can say, OK, wait a minute. This is already a solved problem. Like there are these vendors like New Relic, AppDynamics, Dynatrace, Elastic as well, Datadog. And they have these APM agents. You can put that into your application. And that just magically collects these logs and traces. And it will create these spans for me. That is completely true. This is basically a solved problem. But hear me out. With OpenTelemetry, you have a really unique additional feature here, which is the following. So in the old model, with all these vendors that I just told you, and OpenTelemetry is also like, they also have this outside instrumentation. The model that those vendors and the old model which we had with OpenTelemetry as well is that we have an application. It uses a library, like let's say Elasticsearch or the Kafka call. And the application has this library as a dependency. You, as an application developer, use this library. And then in production, you turn on this monitoring tool. And then what will happen is that from the outside, this monitoring tool will instrument your application. So someone created an Oracle database driver, an Elasticsearch client, a Kafka library. And then these tools from the outside instrument these libraries and magically create spans for it. Now, somehow for spans and traces, we accept this. But imagine this with logs. Like you have a library like talks to a database, and it doesn't create the log. But then let's say OpenTelemetry would create the logs for that library. Now, like no one would accept this model. Like with logs, we never accept this. Like an outside tool doesn't emit logs for a library. But with traces, we do. And why? It's because historically, that's what we ended up having. But this is not necessarily a really good model. So the problem is actually here on the instrumentation side. Because this module, like we have a misplaced expertise here. Like we have the library authors, they spend their whole life creating a library. And then if you want to monitor this, then some other team in some other company creates the monitoring for that. So that's like a misplaced expertise, clearly. The other one is the maintenance. Like libraries have different versions. They come up with new features. And the instrumentation module needs to keep up with that. That's also a huge challenge. The other one is scalability. Like there are countless libraries out there. And you would, as a monitoring tool, you would want to support basically all of that. And also the technical complexity. So like some of these tools like rewrite the bytecode and do monkey patching and these kinds of stuff, which work for a while, and then in some environment, the whole thing blows up. So imagine a world where observability would be truly ubiquitous, like omnipresent everywhere. And for that, we would need baked-in library instrumentation. So the instrumentation would need to live within the library. And this is actually what OpenTelemetry does, or tries to push. And this is what we also ended up with our Elasticsearch clients. So we flipped the whole model. So this is how instrumentation looks like in the current Elasticsearch clients that we that we have. And Elasticsearch clients are not the only ones. So like in many other libraries, already instrumentation is baked in. So the model is the following. You have your application that uses a library as a dependency. And that library has the baked-in instrumentation natively. So the instrumentation lives within the application, within the library source code. And what it uses is the OpenTelemetry API. One key feature of OpenTelemetry is that you have an API and an SDK, and those are two separate things. Like you don't need to, your library doesn't need to depend on the whole OpenTelemetry SDK. It's enough to just depend on an API package. You define how your spans, traces, and logs and whatever look like, and then one SDK, which you can later put into your application, will take care of shipping those logs. So once you are in production, you can actually turn on an OpenTelemetry agent, or what I did in the .NET example is I just turned on this OpenTelemetry exporter, which exported the data to Jaeger. You add that, it takes care of shipping the traces, but doesn't do the instrumentation. So instrumentation lives in the library, and that's like the real thing here. So let's just talk about our story, like how we ended up with Elasticsearch clients and the built-in instrumentation. So, it's not like we just start creating the instrumentation and whatnot, and we just take a dependency on OpenTelemetry and just create the code. There is one really important concept in OpenTelemetry called Semantic Conventions. Semantic Conventions basically defines common names for like different kinds of operations and data. And it's like a common naming scheme, which is like standardized across code bases, libraries, and platforms. So let me show you the actual specs. So this is like the OpenTelemetry documentation. And let's dive into like trace semantic conventions. HTTP call, I think everyone uses a whole bunch of HTTP calls. And it defines, and these are the common like semantic convention attributes. So if you want to know, if your observability tool wants to capture like which HTTP method a certain call uses, then there is this key which you need to use, like http.request.attributes, and then there you store if it's the get or a post or a delete or whatever type of request. Similarly, like the HTTP headers, here it's defined how to capture HTTP headers, and then some other things like the network transport, and all these things are specified in semantic conventions, and every OpenTelemetry instrumentation which emits OpenTelemetry data needs to respect this spec. So, everyone knows how to actually capture, let's say, the request method because it's defined here. So that's a really important concept in OpenTelemetry, semantic conventions. And of course, we needed that for Elasticsearch as well, because it's not that we just want to randomly capture somehow that you talk to a specific cluster and send it somewhere. We really want to specify it. So what we started up with is we created a semantic convention specification for Elasticsearch. So if you look at let's go back to the semantic convention specification from OpenTelemetry. This is the one for databases. And it basically, defines, like, let's say, database systems. Like db.system is the key that you need to use when your instrumentation captures which database system you use. Like, Oracle, MS SQL, or Elasticsearch is also one of those. And then on top of these common attributes, we created one for Elasticsearch. So if you dive into that, here you see how you need to capture Elasticsearch calls. So we say, oh, db.elasticsearch.node is the one where you need to store the node name. And this is a specs, and this is completely open source. Anyone can use it. So once you have this spec, it means all your implementations, tracing implementations, needs to follow this spec. We ended up creating this. It got accepted, and so now there is this spec for Elasticsearch. I want to show you another demo. In this demo, we will have the exact same setup. I showed this to you in Jaeger. I want to show this in Elastic APM. That's a product which we as a company have. just one aspect. So it's the exact same instrumentation, but instead of pointing it to Jaeger, we point this to Elastic APM. We have the same water flow charts with the span, but based on this data, you can also do things like create a list of dependencies with nice icons. Like we know this is an Elasticsearch instance that we talk to, and then we have this in our product. Other vendors can do exactly the same. Other thing which we have is a service map. Obviously, again, we just show a nice icon for Elasticsearch, and we do this based on the semantic conventions keys which are in the spec. So once the instrumentation uses the semantic conventions, we know what the spec is. We know, as I showed you in here, we know that once something has these attributes, then it's Elasticsearch. So we can draw nice icons and whatnot. So this is the huge benefit of having a semantic convention specification, and anyone can take advantage of this. So we have the built-in instrumentation in the Elasticsearch clients. If some other vendor wants to have nice icons based on this, they can do it as well. So there is nothing proprietary here. That's about the demo. And then obviously once we had the semantic convention specification, we have Elasticsearch clients in many languages, like in Java, .NET, Ruby, Node.js, whatever. So we just took a dependency on the OpenTelemetry API, and then our library out was just created the built-in instrumentations. Now, obviously, there are a whole bunch of challenges here, like first of all, you need to, we have people who really full-time work on Elasticsearch clients, and obviously they, jumped on this and wanted to completely over-engineer the whole things and create countless spans for every single Elasticsearch call, and, create one representing the serialization when you talk to Elasticsearch, and then, 4 or 5 other ones which I didn't even understood. And then we ended up with, no, this shouldn't be that complex. So, we ended up with a single span always representing one call to Elasticsearch. Naming is another fun one. We had a whole bunch of discussions around that, because originally we just took the queries as the span name, and then obviously cardinality just blew up, because typically if you create spans for some dependency, then you want to group those, you want to have multiple groups, but the number of groups should be limited. And then we ended up something which included IDs in the span name, and obviously that you can never group something like that. Again, this is a back and forth discussion. Overhead is always a topic, and then not collecting sensitive data. So we could capture the Elasticsearch query, but then what if it contains some sensitive data? So, a whole bunch of discussions around it. And here is the benefit of, having the library authors involved. Once you get rid of them, get rid of their idea of over-engineering the instrumentation, then their knowledge about the library itself is super useful. Since we are at Open Source Monitoring Conference, these are, you will have the slides afterwards. These are real pull requests in open source, which basically show this journey. So this one is the PR for creating the semantic conventions for Elasticsearch in the OpenTelemetry repository, and then you have other ones for specific clients. Obviously, don't wanna go too deep on this. One other thing, Elasticsearch is not the only library that has this built-in instrumentation. So just out of the blue, I run into this one, which is adding the exact same built-in instrumentation to the RapidMQ.NET client. So they plan to have details don't really matter, they call it activity in .NET. Whatever the point of this PR is, having built-in instrumentation in the RapidMQ client, similarly to what I showed you. And then it will just always create these spans that I showed you, similarly to the Elasticsearch ones. You will have built-in native instrumentation in RapidMQ as well. So what's the future here? Because the picture I painted here is like this, perfect world where everything has built-in instrumentation. You don't even need APM agents, and then you just magically have this data out of the box. Obviously, that will never happen. So what we will have realistically is a mixed world. So we would have still agents which do outside instrumentation from the outside, plus we will have libraries which have these built-in instrumentation. One last resource is the OpenTelemetry registry, which shows you, so you can basically check different libraries and the state of the libraries. Like, do we have instrumentation for it? Where is the instrumentation based on OpenTelemetry? And what's the status of this instrumentation? Like, you can search for Elasticsearch, and then you can see, okay, it points you to a few resources where you have the instrumentation for Elasticsearch, and you can. This is like a registry, like just figuring out, is OpenTelemetry covering this library, and if so, then how does it cover that? And that's it. So if you have any question, then I think we have some time left. Yeah. Otherwise, thank you.